This is 6.6 polynomial expansion, and our goal here is to expand and simplify the polynomial. So example 1 is to rewrite each of the problems in expanded form and then simplify it. So in A, x plus 1 is basically all you can do. There's no way to expand that polynomial, so that's why there's nothing written for A, so that is the answer. B, when you see x plus 1 squared, that means you're writing x plus 1 twice. So the expanded form is x plus 1 times x plus 1. And then you're going to use the box method or FOIL to multiply x plus 1 times x plus 1. And so first is x times x, that gives you x squared. Outer is x times 1, that gives you 1x. Inner is 1 times x, that also gives you 1x. So you add those together to get 2x. And then last is 1 times 1, which gives you 1. So that gives you x squared plus 2x plus 1 when it is simplified. In C, you have x plus 1 to the third power. So that would be x plus 1 times x plus 1 times x plus 1. Okay, so if you FOIL x plus 1 and x plus 1, we know we get x squared plus 2x plus 1. So we can take the last two and do that. Multiply those together. We have x squared plus 2x plus 1. Now we want to distribute the x into all three of those and then distribute the 1 into all three of those. So x times x squared is x to the third. X times 2x is 2x squared. And x times 1 is x. When we distribute the 1 times x squared is x squared. 1 times 2x is 2x. And 1 times 1 is 1. And then we're going to combine like terms. The 2x squared and the x squared gives us 3x squared, and the x and the 2x gives us 3x. So we end up with x to the third plus 3x squared plus 3x plus 1. Now we're going to look at Pascal's triangle. So expanding polynomial seems kind of easy, but imagine if you had a polynomial to like the 10th degree or the 100th degree. So Pascal's triangle is a way of expanding polynomials without having to FOIL multiple times, okay? Without having to do the box method over and over. So Pascal's triangle tells us, basically, when you have two things here, you add them together to get this. 1 plus 1 is 2. 2 plus 1 is 3. 1 plus 2 is 3. So you have all ones on the left side, all ones down the right side. And then the way you get the middle numbers is adding the two above them together. So 1 plus 2 is 3. 2 plus 1 is 3. That's how you get that row. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. For the next row, 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. And 10 plus 5 is 15, and then 5 plus 1 is 6. And then for the last row, 1 plus 6 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is 35, 15 plus 6 is 21, and 6 plus 1 is 7. So now we're going to look at the examples. So example 1 says to expand and simplify x plus y to the fifth power. So we're going to use the x and the y. And we're going to be multiplying them together. So we get since it's to the fifth power, we know we're going to use the fifth row here. 1, 2, 3, 4, 5. The fifth row is 1, 4, 6, the fifth row is the second. So that's 1, 2, 3, 4, 5. So it's 1, 5, 10, 10, 5, and 1. That's what we're going to be using. So we're going to put a 1 in front of this, 1, and we're going to say x to the fifth power and y to the 0 power, plus, then we're going to go to 5, and we're going to go down, x to the fourth power, y to the first power. Then we're going to go to the next one, 10, x to the third power, y to the second power. Then we're going to do 10 again, because remember we're following this row down here. X to the second power, y to the third power. Then we're going to go to 5, x to the first power, y to the fourth power. then we're going to finally end up with 1 x to the 0 power y to the 5th power. Now remember, anytime you take something to the 0 power, you can basically cancel it out. So at the end here, you're just going to get y to the 5th for that last term. And at the beginning, you can cancel out the y to the 0, so you're just going to get x to the 5th. Now, this is 5x to the 4th y. This is 10x to the 3rd y squared. This is 10x squared y to the 3rd. This is 5x y to the 4th. And then, like we said, that's y to the 5th. So you have expanded the polynomial. Okay? Let's do this with example 2. We're going to take this to the 3rd power. So on the 3rd power, we have 1, 3, 3, 1. We look at that row. The way you know what row to look at is this is the 1st, 2nd, 3rd, 4th, 5th, 6th, and this takes us all the way to the 7th power. So 3rd power is 1, 3, 3, 1. So we're going to take the 2x and the negative y, because see the minus there means it's a negative y. So we're going to use the 1, 2x to the 3rd, negative y to 0. Then we're going to use the 3, because that's next in the row, 2x to the 2nd, negative y to the 1st. We're going to use the 3, 2x to the 1st, negative y to the 2nd. Then we're going to use the 1, 2x to the 0, negative y to the 3rd. Remember, those numbers come from the Pascal's triangle, and you work your way down. So x starts with the 3rd power, then goes 2nd, 1st, 0, and y starts 0, 1, 2, 3. So anything to the 0 is just 1, so it cancels out. So you have 1, and then you have 2x to the 3rd power. So 2x to the 3rd power, 2 to the 3rd is 8, and x to the 3rd is x to the 3rd. So that's our first term. Next, you have 2x squared in here. So that is 2 to the 2nd power. That gives you 4x squared. And we're going to keep that 3 in front. Negative y to the 1st is just negative y. So then we're going to go to the next one. That's 2x. Negative y to the 2nd. So negative y times negative y is just going to be y squared. If you take a negative y times a negative y, a negative times a negative is a positive. So that's y squared. And then at the end, remember anything to the 0 power goes away. So you just have negative y to the 3rd power over here. So 8x to the 3rd, we're going to simplify this. The 3 times 4 gives us 12x squared. Okay. And then we should have a negative y with it. So that negative y should be right there. So minus 12x squared y plus 3 times 2x is 6x, and then y squared. So 6y squared minus y to the 3rd. And that's our final answer. So remember, we're missing the y right here. So this second term, 3 times 4 is 12, and then there's a negative. That's why you get negative 12. And then you have x squared and y. So there should be a y right there beside the x squared. So we'll go to example 3. Expand 2m minus 1 to the 4th power. So remember, to the 4th power is going to be 1, 4, 6, 4, 1. So we're going to start with 1, and we're going to use 2m to the 4th, negative 1 to the 0. Then we're going to go 4, 2m to the 3rd, negative 1 to the 1. 6, 2m squared, negative 1 squared. 4, 2m to the 1, negative 1 to the 3rd. And then lastly, 1, 2m to the 0, and negative 1 to the 4th. All right, so 2m to the 4th power. 2 to the 4th power is 16, and then m to the 4th. Anything to the 0 will go away. 2 to the 3rd is 2 times 2 times 2. That's 8, m to the 3rd. And then negative 1 to the 1 is just negative 1. 2m squared. 2 to the 2nd power is 4, and then m squared. Negative 1 squared is negative 1 times negative 1, which is positive 1. Here, negative 1 to the 3rd is negative 1 times negative 1 times negative 1, which still gives us negative 1. And then here, the 2m to the 0 will cancel out, so we just have negative 1 to the 4th, which is -1 times -1 times -1 times -1, and that is 1. So at the end here, you're going to see 1 times 1. Obviously, that's 1. And at the other end, you're going to see 1 times 16m to the fourth, and that's 16m to the fourth. 4 times 8 is 32, and we have a negative, right? So negative 32, and then m to the third. Then we go here, 6 times 4 times 1, that's 24, and then m squared. 4 times 2 times -1, that's -8, and then m. And then, like we said, 1 times 1 is a plus 1. And you have expanded and simplified example 3. We go to example 4, x minus 3y to the fifth power. So if we're going to the fifth power, we're going to use 1, 5, 10, 10, 5, and 1. So we're going to write them down. 1, and then x to the fifth, negative 3y to the 0. 5, x to the fourth, negative 3y to the 1. 10, x to the third, negative 3y to the second. 10, x to the second, negative 3y to the third. 5, x to the first, negative 3y to the fourth. And then 1, x to the 0, negative 3y to the fifth. So you just make your way down in the exponents. Okay, so in the first one, negative 3y to the 0, anything to the 0 power will just go away. So we have 1x to the fifth, which is just going to be x to the fifth. 5x to the fourth and negative 3y to the first. Well, negative 3y to the first is just negative 3y. 10x to the third and negative 3y squared. Well, negative 3 squared is 9. Negative 3 times negative 3 and y squared. 10x squared and negative 3y to the third. So negative 3 to the third power is negative 3 times negative 3 times negative 3. That's negative 27 y to the third. 5x and negative 3y to the fourth. Negative 3 to the fourth power is negative 3 times negative 3 times negative 3 times negative 3, which is 81. And then we have y to the fourth. And then remember, anything to the 0 cancels out. So we have negative 3y to the fifth power. That would be negative 3 times negative 3 times negative 3 times negative 3 times negative 3. It's negative 243 and y to the fifth. So that's going to be our last term, negative 243 y to the fifth. And remember, our first term is just 1x to the fifth, which is just x to the fifth. Now, 5 times negative 3 is negative 15, and we have an x to the fourth and y. 10 times 9 is 90, and we have an x to the third and y squared. 10 times negative 27 is negative 270, and we have an x squared and y to the third. 5 times 81 is 405, and we have an x and y to the fourth. And then lastly, 1 times negative 243 is just, like we said, negative 243 y to the fifth. So these are all your examples on how to expand and simplify polynomials, and you definitely want to use Pascal's triangle as you go through that process. So write these down, go through the video again if you need to get a deeper understanding of it after you've written it down, and you will use this to complete the 6.6 worksheet.